Good morning, everybody. My name is Alessandro Provaggi. I'm head of the DAC Plus technology platform at EuroTempower. EuroTempower is the district heating association in Europe, and we are happy to organize this webinar together with Celsius. Celsius Heat is a network providing support, advice, guidance to cities to establish and construct district heating and cooling. And let me say a few words also about the DAC Plus technology platform, which is part of EuroTempower, and we are de facto a European hub for research and development in district heating and cooling as well. So the topic of today is, as you can see, is reusing heat. I think as a society, we all feel quite bad when we waste food, but we don't feel actually equally bad when we waste heat. And our purpose of today is actually to make you all feel a little bit more bad about it. And that's why we're going to start describing what this project is about. ReUseHeat is a European funded project. I'll be the moderator, and please really try to let's try to make this webinar as interactive as possible, so you actually have the possibility to write question in the chat box, so you have a chance to actually ask a question specifically to the presentation after the presentation itself, and then we will have a debate afterwards. And again, you will have a chance to intervene by writing something in the chat, and I will read it aloud for everybody else. We have a very good high-level group of panelists with us today to describe this topic. Christina Lignerund from IVL, Senior Project Manager. IVL stands for Swedish Environmental Research Institute. And let me add also Vice Chair of DAC Plus. Alexander Boy Peterson, consultant from Grun Energy, Danish District Heating Association, and Marta Ruthka from BS Energy, which is Veolia subsidiary. I guess I'll actually give the floor immediately to Christina Ringerund to explain what the ReUseHeat project is about. And I can, as you already, I guess you understood, it's about enabling recovery and reuse of excess heat. And there is actually a quite good focus on the business model aspects. So yeah, Christina, I'll pass the floor to you.
Thank you. I'm going to share my screen. Let's see, it seems to work. And then I make it a large picture. So we're just waiting for that. Okay, so thank you for inviting us here today to talk about the ReUseHeat project. It is actually a result of close interaction with Celsius in the proposal phase that led to the final proposal. And we have built on many of the ideas that were presented in Celsius to gain our project. What we have done is we have focused on low temperature waste heat recovery in Europe, and we have 4 demo sites to prove that it can be done, because our idea is to stop wasting heat the way we do. As Alessandro said, we wouldn't waste food, but we're wasting heat daily. And we think that the heat that people generate in cities by just being part of them, walking around in them, living in them, taking the subway, could actually help to heat the cities. So cities could, in principle, heat themselves partially by just taking care of the heat flows. The ReUseHeat project is a large project entailing 9 countries and 16 partners, and IVL coordinates the project. It has a budget of 5 million euro, and it's a Horizon project, an innovation action, and our demo sites are at a high TRL level 8, which means that we are developing solutions that are close to being taken to market. The project kicked off last year in October, and it's a 4-year project. As I mentioned, the whole idea is to save energy and to help the decarbonization of Europe. The 4 demonstrators are based on 4 different heat flows. We are, for example, taking heat from the sewage water in the city of Nice. We're taking heat from the metro station in Bucharest. We're taking heat from the cooling process of a hospital in Madrid, and heat from the cooling center, the cooling of a data center in Brunswick. And those of you who are familiar with the Celsius project, you see that both sewage water and metro heat recovery are a similarity. Our 4 demos will generate a primary energy saving of about 5.5 gigawatts per year, and we will also save substantial amounts of carbon dioxide emissions, about 1.1 ton per year. And this is, as I said, our vision for the heat recovery in cities. By taking the metro, by using the sewage system, by going to hospital where you need cooling, and also by resorting to IT technologies in computer centers, a lot of heat is generated that can go back into the use of smart cities. Alessandro also mentioned that we have a strong focus on the business aspects, and this is a little bit the learning from Celsius. We are continuing the work that was done there, and we have a dedicated work package on business modeling and contract writing. And apart from that, we then have other work packages focused on identifying the urban waste heat potential. As you know, probably there have been Heat Roadmap Europe programs before, but they have not focused so much on low temperature heat sources. So this is a continuation that we do. We focus on the business side, as I said, and then we have our demos. It's full focus on them. We monitor the demos, and then we exploit and try to replicate the results, and also have communication and dissemination. And in regards to the replication, I just want to mention that we are looking for demo sites where we can make feasibility studies. We have funding and time for that within the project. So if you know of a relevant demo site, please contact us, and maybe we can help you to develop a feasibility study. In terms of timing, as I said, we started in October last year. We are already making good progress with our potential identification of waste heat. Alexander, who is going to present after me, is presenting one of our first deliverables on this topic. On the business model side, we are already starting to get an understanding of the kind of contracts that are needed, and we are looking at common denominators amongst the demo sites and their business models. The demonstration has begun well, and we are on track with all 4 demos. We have also started to develop the KPIs to manage the demo sites, and that is also advancing well. And the other elements are more of a coordinating matter. I also want to mention that we have a large group of brilliant people, and here you can see a picture of them. And this group is also supported by an advisory board and a stakeholders group, which takes part of our results and our work on a more intimate basis. yeah, so that's the overall presentation of the project. I don't think there are any questions for me as of yet, so I leave the floor to Alessandro. Thank you.
Thank you, Christina. If there are already questions, please feel free. In the meantime, since I don't see any, maybe I'd like to ask you, Christina. I mean, there is a lot of discussion about different generations of district heating, third, fourth, even fifth. Sometimes we see. Where does ReUseHeat fit in, and in general waste heat?
Yeah, okay. So as you say, there is a lot of discussion about all these generations. And third generation, just to make it clear, it's high temperatures and one central production unit, as you all know. And then fourth generation, then you have lower temperatures in the system. And then fifth generation, that's when you really have very low, almost cold district heating in islands that you connect. So I would position the ReUseHeat project in the transition between the third and the fourth generation, because we take low temperature heat sources and we put them into existing district heating systems. And whenever needed, then we elevate the temperature of the low temperature heat sources by heat pumps. So we're somewhere in the facilitation of transitioning from third to fourth, I would say.
Yeah, okay. Thanks for that. So we'll pass to the next speaker, with Alexander Boye Peterson, who I said before is consultant for True Energy in the Danish District Heating Association. Alexander, maybe I'll leave to you to describe what is the relations between these two organizations. And Alexander will also give us a nice overview of a deliverable, actually, of the project that they already went through, where they analyzed some demo cases on urban waste heat recovery in Europe, and they had a focus on the Denmark situation. So, Alexander, the floor is yours.
Yes, thank you. So, as you mentioned, I will present some cases on urban waste heat recovery, especially in Europe and Denmark, especially. And I'm from the Danish District Heating Association. So we manage the interests of the district heating companies here in Denmark. And our role in the ReUseHeat project was one of the first deliveries to produce a catalog with cases from all around Europe. We found 24 cases of good examples on how to use excess heat at low temperatures. So our role was to exploit these cases, present them, participate in workshops around the demonstrators, as Christine mentioned, all around Europe, to present some of the good cases from Europe. And these are all some small-scale inspirational projects on how to utilize excess heat from urban sources, low temperature, and used for both district heating and cooling purposes. And the focus, of course, is on heat sources related to the ReUseHeat demonstrators. That is the waste heat from data centers, sewage or wastewater, hospitals, and also underground stations. So this is an overview of the cases that we found, 24 cases, of which most of them are in Denmark. They are all based on a lot of different sources of energy, as you can see. We have wastewater, sewage water, supermarkets, different industries, even crematories in Denmark, where we gather the excess heat. We have storage facilities, electrical converter stations, metros, mining, data centers, harbors, and hospitals. So in total, a lot of different sources of energy where excess heat previously was just lost in the air, but now is gathered and used in district heating networks, both heating and cooling purposes. So in Denmark, I will focus on 3 cases in detail in the presentation. The first one is in Kalundborg, where they use wastewater water as a heat source. The second one will be in Høje-Taastrup, where they're exploiting a potential for co-production of heat and cooling, which enables synergies between a local vegetable market and the district heating company. And finally, I will present a case from the Rødkærsbro district heating company, where they also use industrial wastewater from a dairy to produce it. But first, I will tell you a little bit in general about district heating in Denmark. We have a broad system of district heating in Denmark with 460 district heating plants, both based on boilers, CHPs, and industries, both decentral and central. As you can see in the map, all the blue ones is the district heating networks, while the yellow ones is the natural gas network. So we have a vast system here, which is also why we have a big system to exploit the excess heat, to utilize it. We have multiple sources of energy where we use coal, biomass, natural gas, waste, and biogas, but also renewable sources such as solar, electricity, and geothermal energy. And the total network is more than 40,000 kilometers of district heating network, and we supply nearly 2/3 of all residential houses in district heating. So you can say that Danish district heating network is quite immense. But to take the first case, as I mentioned, is Kalundborg, where they have this large central power plant, which is currently being converted from a coal-fired power plant to being a biomass-fired power plant. And during this conversation, the district heating plant, a company, found that they needed something else while in periods when this big power plant was shut down. So they decided to construct a 10 megawatt heat pump to produce district heating, which is used during this conversion of central power plant to coal from coal to biomass. And it is actually a heat pump which utilizes nearby wastewater from the wastewater treatment plant with wastewater temperatures above average due to a local industry, Novo Nordisk, Novozymes. And actually, the wastewater is used in 3 steps. The first step, it is used for industrial processes at Novozymes, where heat is used to withdraw organic content, which is actually used for biogas production. In the second step, the wastewater treatment plant utilize the temperatures between 20 and 35 degrees to accelerate biological processes in this wastewater. And finally, the district heating company utilize low temperatures, 5 degrees, to recover heat and use it in the district heating system through this 10 megawatt heat pump. And wastewater is finally cooled to 10 degrees before it's sent out. So you can say that that's taking a lot of energy out of this water. So we have some quick facts about this case. We have a 10 megawatt heat pump. Heat source is wastewater. We operate with a heat pump COP somewhere between 3.6 and 4.0. Currently, a lot of operation hours, up to 8,000 hours in the first 2 years during the downtime of the power plant. After that, they expected to run about 900 hours. The total investment for this heat pump was approximately 7.25 million euros. But there's a lot of savings, above 30,000 euros every week until 2019, because they have these immense savings. And yes, that was the first case I would present. The second case from the catalog we found in Denmark was in Høje-Taastrup, where we use excess heat from a vegetable market. In 2016, the old vegetable market in Høje-Taastrup was replaced by a larger centralized market called Copenhagen markets, which is new and comprehensive vegetable market with a large cooling demand. So the plan was to use low temperature heat from the district cooling to produce district heat. So it's like a cooperation between the heat side and the cooling side. And Copenhagen markets has a total area of 67,000 square meters of market. And by utilizing combination between district heating and district cooling, you can replace a lot of the old refrigeration units, which lowers the overall energy consumption and benefits the environment. So it's a system that co-produce heating for the district heating network and cooling for the market, where the cooling cannot be lived without the production of heat. So it's a great utilization of the synergy between industrial cooling and district heating. As you can see on the figure here to the right, district heating network operates with standard temperatures of 70 and 40 degrees, while on the cold side, temperatures is delivered at around 6 degrees, but actually cooled to -8 degrees using some extra chillers, and then return to the district heating at 16 degrees. And in H2020 in general, they found that district cooling proved to be a very important part of future urban development in the area, both for comfort needs and process needs, such as the one in Copenhagen market. So there is a large potential for district cooling in the area surrounding Copenhagen markets. And you can see they divided into 3 groups, where the green area, one is nearly 50 megawatts of cooling potential, and smaller groups a bit out of the area here. So the total cooling potential is 56 megawatts in H2020, which is just a small area of Denmark. So it's a large potential in Denmark for district cooling and the collaboration between utilizing the excess heat from the cooling side in district heating systems. So to sum up the facts about this case, the total floor area in the market is 15,000 square meters. And of course, there is a cooling capacity, which is 2 megawatts, and a heating capacity, which is 2.3 megawatts. And this operates with COPs of around 2.2 for the refrigeration unit and 3.2 or 1 heat pump COP heat side. And the total investment was approximately 3.4 euros. And currently, the heat pump can contribute with just 3% of the total heat consumed in the area of H2020. But you can say that it is a very cheap form of energy to use, a good potential to be developed even further in the area. And the final case I will present from the catalog of 24 cases is also from Denmark, as I mentioned. It's in Rødkærsbro, which also has a district heating company. They use industrial wastewater from a dairy. And previously, heat from the dairy was just discharged directly into the stream at temperatures vary between 20 and 30 degrees, something like that. But they decided that the district heating company dairy is not so far away after all, so they can actually use excess heat from the dairy in the district heating company through a heat pump to deliver heat to the system. So the project here was to utilize excess heat from the dairy with temperature between 22 and 25 degrees. The dairy also found that there potentially in the future could be some requirements for the emission of discharged wastewater into the stream. So instead of discharging it at high temperatures, they could cool it with heat pump and potentially avoid environmental risks or requirements. And for the district heating company, they found this was achievable. But one of the challenges for this project was a long distance from the source, which was at the dairy, to the heat pump at the district heating company, and also how to optimize this heat pump. But as you can see in this figure, it is actually quite a long process. Where manure is used to produce biogas at the dairy. The dairy then has their own gas engine generator to produce both electricity, the general power grid, but also high temperature heat for industrial processes, cheese dairy. Then they also have this amount of excess heat, which is then gone through some heat exchange and sent to the district heating company, which then have the opportunity to use electricity and produce heat and accumulate it in their storage tanks, deliver it to the district heating network. So here they can replace natural gas as the district heating plant, and wastewater is boosted to these temperatures of 67 degrees, which you could call low temperature district heating. And from the side of the district heating company, they gained a lot of cheaper district heating production from this excess heat. As this figure shows, you have heat production costs and price of electricity. And for the natural gas engine, which is the yellow one, as the electrical prices increase, of course, it becomes cheaper to produce heat from the. And it's opposite with the heat pump. As the price increases, it becomes more expensive to produce heat. But in general, the cost of producing heat on the heat pump is a lot lower than the production cost from the gas engine. They have the opportunity to save a lot. So to sum up the facts about this case, they installed this heat pump, which is relatively small compared to some other Danish cases. Examples 1.6 megawatts. They exploit this low temperature industrial wastewater and actually obtain a quite high COP of 4.6. An okay production of 6,500 megawatt hours every year, and a relatively small investment cost of 1.8 million, which they had some grants of about 300,000. So the payback period for the system was 7 years. But since the project was finished, they have experienced a little bit change in the performance of the heat pump. They're running with a little bit lower COP than expected, but it's actually due to a change in temperatures in the diary, which no longer is just about 20, but below 20, actually around 17 degrees. That was due to the diary optimizing their own industrial processes, which lowered the wastewater temperature. So they're not getting as much energy from the heat pump as expected, which also reduced the capacity from the heat pump with 300 kilowatts. But as these figures to the right show, it's line down here, the bottom one is this COP performance over time, which is quite stable, you can say around the 4.5. And so even though they gained these lower temperatures, actually have quite good. So that was what I had now. You can of course find this catalog ReUseHeat site, our own site at Gartland.org, where you can find all the 24 cases that we have for your interest. Yes, that's what I got now.
Thank you, Alexander. We actually do have a question from Katrina Folland, who says, very interesting. Can you say something about the ownership and how to convince, well, in this case, the vegetable market and dairy to be part of the district heating and cooling system?
Well, I don't have any specific details from the cases, I would say, on contracts or anything like that. Of course, there is potential for both parties to save some money here on the utilization of excess heat. Of course, district heating can gain a cheap source of energy using this excess heat, and they can actually sell the cooling. I mean that the industry or company can sell the excess heat to some degree. So
could I add to your comment there, Alexander? This is Christina.
Yes.
So what we see is that it can be a win-win situation for both the district heating provider and, in this case, then the vegetable market. But the thing is that this kind of relationship becomes a bit more close than a usual heating and provider net distribution relationship. So this is what we're working a lot on in ReUseHeat, to understand what are the best and most efficient contractual boundaries and how do we create the win-win situations so both parties are comfortable. Thank you. I just wanted to add that.
Yes, and thank you, Christina. And of course, it's you can always say that it's a great risk for the district heating company if the business industry is closed. This large investment could potentially be wasted. So, of course, there's a lot of different things to consider.
Yeah.
I think.
Alexander, your connection is not optimal, so I'll invite you to actually connect via the phone. I think is better, so you can disconnect and try to reconnect via by dialing the phone. Thank you for doing that. In the meantime, we are gonna go to our third speaker, and Marta Ruska from BAS Energy. What Marta will present is really a case study out of the ReUseHeat project. So Marta, the floor is yours.
Thank you very much, Alexandra. Okay, can you see my screen?
Yes.
Okay, perfect. So good morning, everybody. One more time, my name is Marta Rucka, and through ReUseHeat project, our Volia team is implementing demonstration of excess heat recovery from data center in Braunschweig, Germany. The Braunschweig demonstration site is run by Volia's subsidiary BAS Energy, which is a local energy provider for electricity, heat, gas, and water in the city of Braunschweig. Today, I will shortly describe our town and the district heating network and the heating market here. Then I will shortly introduce you to our demonstration. I will describe main idea of the project and main technical issues. And at the end, I will have a short discussion under replication potential. Braunschweig is also called Brunswick in English. It's located about 250 kilometers west from Berlin, or 60 kilometers east from Hanover. And today, with 250,000 of inhabitants, it's the second largest city in the Lower Saxony region, just after Hanover. And it's a center of scientific research and development. While in the past it was a center of the culture, it's a historical town with 1,000 years of history. BAS Energy owns and operates the district heating grid and the supplying power plants in Braunschweig. We have 250 kilometers of central district heating, plus 11 kilometers of decentralized grids. With this district heating network, BAS Energy serves about 8,000 heat customers in Braunschweig, including 56,000 of houses, apartments, commercial and municipal buildings. And we are covering approximately 45% of the total heat demand. Heat is generated centrally at 2 combined heated power plants, and we have also 2 peak boiler stations, which are located south and east of the town. Our demonstration site is located southeast of the town. For our Braunschweig demonstration site, the customer is a newly built energy efficiency housing area. Just next to this area, a data center is currently under construction. Both investments are actually on their early phases of construction, while data center is a bit more advanced, but we expect that equipping process for the data center will be a bit longer. So these two investments should be following parallelly and be ready for delivering the heat together. This location, data center just next to the residential area, in our case, makes a perfect match because long distance between data center and the customer might be a kind of strong obstacle against this kind of demonstration. And there is also a plan to introduce a commercial area just next to the data center and the residential area. But this investment is not confirmed yet, but we hope that in the future, if this investment will be developed, it can also benefit from excess heat from data center. This simple sketch illustrates the main idea of the project. We have a residential area with 400, it can reach up to 600 housing units. We have a data center with many megawatts of thermal energy of excess heat. And the data center operator transfers its excess heat to the cooling water cycle. Then cooling water cycle is forwarded outside of the data center where it's used to supply the heat pump. Warm side of the heat pump is feeding the low temperature district heating network. Low temperature district heating network is under construction right now. There were no district heating networks before implementing this project. While the cooling water cycle is cooled down by the heat pump and able to uptake the heat from the data center again. And there is also a connection provided by the high temperature district heating network to ensure flexibility and demand peak shaving. The low temperature of the heat source in our first approximation, it will be about 20-25 degrees, implies using a heat pump to increase this temperature to the satisfactory level. And at the same time, the temperature level of the district heating network should be as low as possible to maintain high efficiency. And while we have a kind of strong regulation in Germany about Legionella sanitary issues, so there must be a trade-off between the technical efficiency of the system and the sanitary concerns, while this 65 degrees could be favorable for developing Legionella bacteria. Without implementation of the waste heat recovery system, the energy for this housing area probably would be provided through conventional decentralized gas boilers. And we estimated primary energy factors in the case with heat recovery and without heat recovery, and it was calculated that primary energy savings in our case can reach up to almost 1,300 megawatt hours per year, which was also translated into a global greenhouse gases emission savings of more than 300 tons of CO2 per year. When we talk about waste heat recovery from data centers, it's very important to be aware that there is a huge potential of excess heat from data centers, and it will grow also in the future, which should be used. And most of the power consumed by the information technology equipment is converted into waste heat, which must be removed to avoid possible damages to the equipment. That means that the data center requires constant cooling to maintain a moderate climate in the computer rooms. And the energy required of the cooling system can represent up to 40% of the overall data center energy consumption. And this excess heat produced during the cooling process by data center can be, for example, discharged to the ambient air through so-called free cooling. But that would be the best if we can reuse this heat for heating purposes, as what is our main objective in German demonstration site of waste heat recovery from data center. Thank you very much. If you have any questions, please tell me, let me know.
Thank you very much, Marta. Yes, if you have any question for Marta, please let us know. There is actually a question from Koen Enkels, City of Antwerp. Well, actually, it's for Alexander. Are the cases available? The cases catalog is available online, Alexander. I think so, right?
Yes. The cases are available both on the ReUseHeat website and on our own website.
Yeah, and they apply, as you I think probably also said, they are not just from Denmark, but they apply. I mean, they are also from different areas of Europe. So
yeah, so half of the cases are Danish examples, and the rest half is from all around Europe. Yeah.
Okay, so we can start with the let's say the part of the debate. For the audience, please don't hesitate to type questions, even provocative questions, to feed the debate. What I can say from our perspective, being a European associations and based in Brussels, and having a lot of discussions with the European institutions, in general, we feel that there is more now, a little bit more at least, awareness on the untapped potential of waste heat. We are definitely trying to promote awareness in this sense, and people are starting to be interested in that. Still, there are many open questions, and my impression that sometimes the questions are not really technological, but are more related to basically the business models, or anyway the type of contracts and business relations between the potential provider of excess heat and the district heat company. May I ask to the panelists, in your experience, what works and what doesn't when it comes to the cooperation of the district heating company and the industry for which is a potential provider of excess heat? Maybe Alexander, we can start from you.
Well, I'm not an expert on that, so I think maybe Christina or Marta should answer this question.
Well, this is Christina. Maybe I could try to give an answer. I also do research part of my time, and I just finalized a study on waste heat recovery investments, and how large the risk is that you can go bankrupt if you now heavily invest and then the industry goes out of business. What is the risk for this? Because this is something that is often mentioned and discussed a lot when you try to enter this kind of cooperation. And when we quantify the Swedish experience from the past, since 1974, so over 30 years of operational data, we see that this risk is about 5%. You lose about 5% of the corporations, which really means that it's not such a big risk that everybody talks about. So that's partially an answer to your question. And then we see that in order for a cooperation to work, you need to have a good collaboration and trust between the two parties. It's like the softer values, the cooperation and the trust are very important for a long-term relationship.
So basically, Christina, you're also saying that the cases, when the success cases is also when people actually know each other more, and they already work together, or that at least there is a wider sense of trust in among the two organizations.
This is what we saw like in the long-term collaborations. They kind of develop this symbiosis relationship over time. So they become dependent on each other. And that is a good guarantee for a long-term relationship. But then we also saw that if you include the component of electricity, I mean the usage of heat pumps to elevate the heat of the waste recovery, then often the collaborations are shorter and they are more risky, because then you become dependent on the electricity price as well. So there are no ways to know if it's high risk or low risk. And if you have a close interaction with somebody and no heat pumps, it's lower risk, for example.
Yeah. Okay. In the meantime, we got some questions. So I'm going to read actually the one from Donald Gartland, because is actually a question that it fits very well with the discussion we're having now. She asking, was it easy to obtain long-term heat supply contract from the data center? And is there a cost for the waste heat? From Donald Gartland from Codema, Dublin's energy agency. So I think this is a question more for Marta.
Yes, so the contract, as far as I remember, it's a 10 years contract with the data center, and data center will benefit from waste heat, from providing the waste heat for us, for district heating purposes. We should also remember that for data center, there is a double win situation. While providing us the heat, they also reduce the amount of electricity needed for cooling purposes. So in that case, there is not only the benefit from gaining profit from excess heat, but also the profit while the cooling demand will be lower in this case. So for data center, also this case is very important, this aspect.
However,
Okay.
we should add, maybe, Marta, that we had this discussion on the value of the waste heat. And what we realized is that German legislation is not really benefiting the recovery of waste heat in this way, right? So it was more an incentive from Veolia and BSE to make a green investment, and it also fitted the computer center. But yes, the legal environment was not particularly favorable or putting a value on this kind of recovery.
Yes, you are completely right, Christina. And yes, in our case, it's Veolia who wanted to introduce this kind of innovative project. So to gain the experience from this kind of investment. And yes, for Veolia as an international company, that was the main issue. For data center from another side, there were many benefits, also considering the local aspect to develop this kind of solution for the local economy. It's also a very good project. So there are many small issues which are not directly connected to the price of waste heat, while yes, there are many aspects to consider while discussing about benefits from excess heat, in our case from data center.
Okay, I think there is also part of the question refers to the cost of waste heat. I think this is also an interesting aspect. I mean, not necessarily related to the project of Marta, but in general, in your experience for the panelists, how do you actually price the waste heat? What is the how do you start giving a price to the cost of the waste heat?
This is Christina again. So in Sweden, the industrial waste heat recovery is pronounced, and it has been done for a long period of time. And when you look at that kind of studies, often the procedure of arriving at a mutual agreement, it ends because you cannot agree on the price of the waste heat. Because in many cases, the waste heat owner, the industry, thinks that their the value of their heat should be higher than what the district heating company assesses, because it's maybe high temperature, good quality heat. But then for the district heating company, maybe the value is different, because if you get the heat in the summertime, it's not worth so much as if you get it in wintertime. And if you only get it with within certain intervals and not all the time. It's not worth as much as if you have a constant delivery of heat. So that kind of discussion is tricky, and it's something that we focus a lot on now to understand in the ReUseHeat project. But we don't have results from ReUseHeat yet. We just have from the Swedish experience. And in the case of the demo site in Germany, I don't think that the value of the waste heat was discussed at length. It was the whole concept that was discussed. It was more the concept as a whole. Marta, please correct me if I'm wrong.
Yes, in our case, maybe it's very hard to discuss this topic because also contracts are very sensitive issues, and we are always very aware to provide any details about the contracts, while yes, we are also under some restrictions and rules about sharing this kind of information. But that's the point of ReUseHeat. I cannot say directly what's the price, what's the value, but later, as the result of ReUseHeat, we will collect the whole information, providing some kind of guide and the book. And yes, I think the only case in this situation is to just wait a bit and to let the situation develop a bit.
Okay. Not sure, Alexander. Feel free to enter if you have anything to add. Otherwise, I maybe want to mention, Christina, you said at some point that the legal framework was not particularly favorable. Correct? May I ask you what do you mean with that? That there was a barrier, or there was no?
What I meant is that we have discovered that, for example, in Germany, there are other incentives for energy efficiencies or using renewables and things like that. And waste heat recoveries do not fall into that kind of incentives. So if you want to do the waste heat recovery, it's kind of in between legal frameworks. And this is also the case in Sweden, that we don't explicitly have how do you manage waste heat recovery as one point. And we saw it also in Romania in the case of the subway heat recovery, that there you need a permit to recover this kind of waste heat, which is similar to a permit you need to distribute electricity. So it's very imbalanced, and it creates a lot of administration because it's so new and hasn't been accounted for in the legal environment yet. That's what I meant.
Yeah. Marta, there are 2-3 questions actually. I'm not sure if you were able to see them on the general regulation and how do you factor in the carbon emission results from the energy power saved. I have to say that this is a bit out of the scope of the discussion on recovering waste heat, but you can if you can shortly reply about them. Otherwise, you if you have more info, you can send them later on.
Yes, so I will try describe these topics as detailed as possible. Considering the legionellal issue, yes, it shouldn't be lower as 65 degrees for the warming up the water. So we are restricted to this temperature. I'm not completely sure. I should check the regulation again, but it's between 60-65 degrees. That's the limit of the temperature. But of course, I can provide more information about this issue after the conference. The question about carbon emission calculations. So we used factors available on some kind of national or government environment page where it was suggested that factor used in Germany for the efforts needed to extract, transport, and handle, for example, natural gas, which was our first idea if we didn't implement this project, was, for example, 1.1. Then factor used for electricity 1.8. So in our case, we don't use gas, natural gas. We will use electricity, even if the primary energy factor is higher in this case, but the total balance is lower, while the energy used, electrical energy used to feed into the heat pump is way lower than it's needed, for example, in the case of natural gas, if we deliver only the natural gas for heating and domestic hot water.
Okay, yeah, thank you. Then there is another question from Katrina Folland from Gothenburg City. Does trust increase if a city is involved instead of only private partners? Who wants to reply to this question?
This is Christina. I can try. I believe that a city has other interests than private companies, right? So if you are in a situation where you want to inform yourself and get input on what district heating is and how you can build it, I believe it's very valuable to have a neutral partner to talk to, if it's a city or somebody else. So I think in the initial stages, a city and its experience is very valuable.
And may I ask as a follow-up question, does, for example, if there is an agreement between two private parties, the role of the city sometimes is also into the agreement, there is some kind of, how do you structure that from an investment perspective? I mean, in a risk perspective, does the city takes, for example, the loss first rather than the private, a sort of an insurance from the city? There are cases like that.
I don't understand your question. Maybe, do you mean like if one of the parties go out of business and there is a loss, who takes the...
Yeah, who takes the risk? Oh, yes.
Okay, but then I think in different countries, we have different traditions. So for example, in Sweden, there is a tradition to have municipal ownership of district heating companies. Mm-hmm. And if such a company would go out of business for some reason, that the industrial waste heat recovery or so creates a big loss, then society has to cover up, and then of course the city will have to finance this. But in other parts of the world, like for example in the UK now, there is a lot of private investors engaging in the district heating scheme. And then I think primarily that kind of loss will have to be carried on the private side. But of course, you cannot allow people to suffer from a private market failure. So somehow the cities still will have to take the final responsibility.
Yeah. Okay. In the meantime, we have another question. Thank you both of you for answering. In the meantime, we have another question, Francesco Peccianti. Consider the low temperature of the waste heat you are recovering. Are you analyzing the potential impact of upgrading the district heating network towards fourth, fifth generation?
Now, this is out of the scope of ReUseHeat. We just look at the current systems and how would they go about to use this heat recovery. I manage another project, which is an IEA project, where we look explicitly on fourth generation transition and implementation, but that's not the scope for ReUseHeat.
Yes. Yes. Okay. Alexander, if you, I'm not sure if Alexander, do you hear us?
Yeah, I hear you. I can add something to the low temperature, perhaps. In Denmark, we're doing a lot of for finding more potential for low temperature district heating and going towards the fourth generation, because there's a lot of drivers for integrating temperature. You use less electricity from the heat pump, obtain a higher COP, and integrate renewable energy. And you can also, of course, reduce the heat loss in the district heating network. So we actually have a lot of good examples on low temperature district heating, I would say, where you take an area of the district heating network and reduce the temperature from maybe 70 or 80 degrees to 50 or 60 degrees, with good results of savings and heat loss reductions and such. And we also operate some demonstration projects with what we call ultra low temperature district heating, where you actually send the district heating at a temperature of 35 degrees to the houses, which of course is not enough for the domestic hot water usage, but enough for example, underfloor heating. But then you can boost the heat directly at the house in small heat pumps, for example, for the domestic hot water or using electrical boilers. So I would say that the potential for reducing the temperature in the district heating is very large and will help a lot with integration of excess heat.
Okay.
I would like to add to that, just because we have new buildings, and there the low temperatures and the fourth generation is very suitable often. But then we still have a large stock of old buildings, and we have existing networks that we must use somehow as well. So I believe that the big value of ReUseHeat is the transition, as I said initially, to aid in the transition to become a fourth generation system long term. But to work with what we have now.
Yes, of course you cannot go to any lower temperature than the forest unit in housings. So of course it's only a part of the transition.
Yes.
So sometimes one of the barriers identified in actually utilizing more waste heat is the fact that the return of investment is quite far in time. May I ask you, what is your experience in that? What the potential heat providers, when they come, when in the discussion, what they say that to is that really a barrier?
Well, this is Christina again. I seem to talk a lot today. You have to stop me, Alessandro.
Yeah, but there are not so many panelists, so it's like.
So we have done now in one of our work packages, we have done a round of interviews with investors, and we have asked them about different things and the values of waste heat recovery. We've done this with 9 countries, and we have asked people who, for example, manage green funds and things like that. And what we find is that depending on the investor type that you are interacting with, they have different ways of valuing the investment. So if it is an investor who values the green element of the district heating investment, then the long-term investment and the green aspect is very relevant, like a pension fund or something like that. But then if you, on the other hand, talk to a more short-term investor, then the district heating investment and the utility aspect of it is not really adding any value. Instead, it makes it difficult to invest in that kind of investment, because you have to have the long-term perspective and the wish for the green in order to realize the values.
Yeah. Alexander or Marta, do you have anything to add on that? An experience or no? Maybe just like if there are no more questions, I see just 1 or 2 more questions too, and then we're probably going towards the end of the webinar. We were talking a little bit before about the legal framework from a more political aspects. Do you see any shift, any increase or decrease in the political interest for using excess heat as part of the green transition, or there is a lot more to be done?
So this is Christina talking again. When I look back, to 2016. This is when we get the heating and cooling strategy for Europe. And this is also when they start mentioning that industrial waste heat is a very important component for the future. However, I mean, 2016, it's only 2 years since that was on the table. But I think we are gaining interest more and more. And people are talking about industrial symbiosis. We see that in horizon calls and things like that. So it's becoming more apparent. But I mean, we're far away from the levels of using this kind of waste heat that we actually are already using them in Sweden. So I think in different countries, maybe the awareness is greater than in others, but overall it's increasing.
Okay, thank you. We do have a question now from Kun Enkels. The focus of the project on business modeling and how to construct them with wins for all stakeholders is very interesting. Will the project produce documentation and or tools, and if so, when will it be available? So
yes,
yeah.
Yes, we will provide, we have deliverables in this work package. I don't know if all of them are public, I don't remember, but for sure we have one large deliverable that will be public, which will include an entire chapter on business modeling, and it's the handbook, because we write at the end of the project a handbook on how to recover low temperature waste heat sources will come out of ReUseHeat, and it will also be supported by training sessions. So we will with the help of Alexander and his colleagues, we will have training sessions in different parts of Europe, where we will invite interested stakeholders to take part of the contents of the book and learn how to use the contents of the book.
Okay, thank you very much. I think if there are no more topics that want to be raised either by the audience or by the panelists themselves, I think we're going to close the debate. Is any other comment from any of you? No? Well, then I really would like to thank all of you for your time, for your presentation. To the audience, please stay tuned. As Christina made clear, this is ReUseHeat is a project that honestly just started 7-8 months ago. So and will last in total 4 years. So I think it's a good project where also European Power DC Plus is communication work package leader, and we will try to provide a lot of relevant info for making waste heat utilization possible. So thank you very much.
I'm sorry to interrupt you. I just took the opportunity now to put the website for the ReUseHeat project for everybody in the commenting field. So if you want to know more, you can check out our website, but you can also contact me. Please just send me an email or drop me a call, then I will be happy to answer any questions.
We added to the entire audience, we added actually the link to the case study report done by the Grünenergie, Danish District Heating Association. And as you see, the first part is also the website of ReUseHeat.eu. Okay. So again, thanks, and stay tuned. Thank you very much.
Thank you.
Thank you to all of you. Bye. Bye.
Bye.